Okay, so here we're told that three tennis balls with a diameter of 2.5 inches are placed inside a cylindrical container with a diameter of 2.7 inches and a height of 8.5 inches, approximately how much empty space is inside the container. So here's an interesting question that's dealing with the volume of empty space. Our container is a cylinder, right? So the diameter of 2.7 inches. So here, if this is about 2.7 inches, right, this is how wide the container would be. So we draw our cylindrical container here. This is my rough drawing here. And, okay, that's my cylinder. And the height is about 8.5 inches. I should have certainly made it a little bit longer here to make this model more accurate, but I think you get the idea. On the inside, we have these tennis balls, and their diameter is a little bit less. And there's three of them fitting inside. One, let me fix that. One, say, two, oh boy, three. Sorry about this, I could have clearly used a circle tool, but I just want to quickly set this up. So these diameters are 2.5 inches. They want the empty space, so they want the space right here, around the tennis balls, but not filled by the tennis balls. So here I would find the volume of my cylinder, and then subtract the volume of the three tennis balls inside. So how can we do this? Well, the cylinder is just pi r squared, the circle, area of a circle on the bottom of your cylinder, times the height of that cylinder, and that would give you the volume of the cylinder. And then the volume of a cylinder. The volume of a sphere is 2/3 a cylinder of the same height. So here, if we had, let's just say one sphere would be 2/3 the height of a circle, right, times the height. That just means 2/3 of a cylinder, and that's the volume of a sphere. Alright, so if I had a single sphere right here and had a mini cylinder around it, the sphere would fill exactly 2/3 of that cylinder, right, of the same height. So here we have two different radiuses and different heights to look at, so we have to be careful. But let's start with the cylinder. We have a radius of 1/2 2.7, so that's the radius. So 2.7 is the diameter. Divide it in half, we get the radius. We're going to square that, multiply that by the height, 8.5, and then multiply that by pi. So we are estimating here. We'll choose how much we want to estimate. So I'll write this work down here, the volume of the cylinder. So I would definitely use a calculator on this problem. So here in the calculator, when I set this up, I don't have to, I can use parentheses, but I'll set this up in steps. 2.7 divided by 2. So our radius is 1.35. Then I square it. So I've taken care of this first part of the term, of the volume. Then times 8.5, enter, okay, and then times pi. So you'll have a pi button, or I'm going to second exponent for pi, and we get our volume, 48.66719,719. So here they're not telling us how far to estimate. I'll estimate to the hundredths, so 4.67, we round that up. 46.67, double check, do I have it? Oh, no, 48, sorry. 0.67. Now the volume of the sphere, we'll find it a very similar way. We just have to remember to triple it, because we have three spheres. So let me just set that up right now. Sphere times 3. Right, we're going to triple this volume. So notice if we're going to triple the volume, we could think of this as 2/3 times 3. And if you have 2/3 times 3, right, because we are just multiplying all this stuff, so I can multiply 2/3 by 3 first by using the commutative property. 2/3 times 3, the 3's cancel out, and we just get 2. Or you can do 2 times 3 is 6, 6 divided by 3 is 2. So instead of 2/3 and 3, we can just write 2, right, pi r squared times the height. Okay. So here, again, just being careful with the numbers, because we have a different radius and a different height. Our radius is now 2.5, our diameter of our tennis ball, divided by 2. So now the radius is 1.25. So we take that and we square it. That's the radius squared. Times the height. Now the height is going to be the full diameter of your tennis ball. If you turn a tennis ball on the side, the diameter here would become the height. Right, and a tennis ball, the diameter is the same everywhere, so the diameter ends up being the height. So we have the radius squared times the height times 2 and then times pi. Oops, delete that. Okay. Oh, it's mad because I left something there. Let's fix that. See, it thinks I still have an exponent to work with, so let me delete that. Okay. So there's the radius of the 3 tennis balls, 24.54369.261. Okay, well, here, let's say it's 24.54. Okay. 24.54. This is the volume of the 3 spheres, because we tripled the volume of each sphere. Let me just go back and check that. 24.54. Yep, and that makes sense because if you think about 3 tennis balls, right? The height would be 2.5 times 3, which is 7.5. So there's a full inch of space above and below the tennis balls in the container as well as around it. So there's a lot of empty space. So now we just subtract the two. 67 minus 24.54, and that's just, I mean, you could work that out in many ways. I'm going to use the calculator. 48.67, right, minus 24.54, and we get our empty space, 24.13. And that's it. So this would be in cubic inches, by the way. All these calculations, you can write inches to the 3rd power or cubic inches, just to confirm that you have the correct units. Cubic inches for 3D shapes, or cubes in inches, 3D volume, and any flat area, square inches for the flat shape or square. Thanks.